Yeah, I heard from a number of friends that they actually cannot join, but they enjoy watching some of the videos. There's always interesting things to learn. So welcome. This is our fifth roundtable panel discussion. I'm excited to share a couple of things. I had yesterday had a really nice session with Nicholas. We went hands-on, going through green screen from the first, as Brian likes to say, the feature zero is the pipeline, right? And one thing I just want to quickly mention, I really appreciate Brian's presence here, and I'm learning a lot from Brian because he's helping me pull down everything down to planet Earth, which is operational side of it. Once we have operational side sorted, then we can safely move into fancier things, and so I would like to hear maybe later, Brian, if you have any suggestions and thoughts. How do we actually use or leverage AI to make sure that our pipeline is rock solid, that we, like you say, that there's no drama, there's no panic, abandon hot fixes, just make everything smooth and working, firing on all cylinders so that we can then safely go and experiment. We talked a little bit about hypothesis-driven development, validated learning. These are all fantastic things. Another thing I just really want to quickly mention is I was invited by a large government organization to visit them next week and to demonstrate how am I using AI, because they have the Dev AI community of practice rolling, and they're really serious embracing AI and going, if possible, AI native. So that's going to be really interesting experiment. But today I have a few things on my mind that I want to propose, and of course, everybody here is free to throw their own suggestions. One thing is we haven't really finished last time or reached any conclusion as to the reviewing the code in our when we are doing AI assisted or augmented development. Some people say you need to learn you need to review absolutely every line of code, which to me is pretty wasteful, because if I'm qualified to review every line of code, I might as well write it myself. And why would I use AI, right? But the jury's still out, and I would like to hear more ideas about when is a good time to just say, yeah, I'm fine, I'm not going to even look at the generated code, versus no, I have to open the source code and I have to really see what's going on there. And another thing I wanted to propose here, which I put in the meeting invite, is our friend Laurie, I think from South Africa, right? He published to me a groundbreaking article on patterns that are not there. And I would like Laurie to maybe walk us quickly through and then see if anybody has any comments. I found that article really thought-provoking, and I did a lot of soul searching based on that one. Laurie, are you here? Can you take over?
Yes, I'm here. Hello. Yeah, greetings from sunny South Africa. Thank you, Alex, and hello, Luther, and all of the rest who have come to know. I've only been part of, I think, 2 or 3. I missed 2 of these. But yeah, thank you for the compliment, Alex. It's something that is, in my opinion, quite important to write about and to talk about, because of the fluency of the state-of-the-art frontier models. There's a real human element to this, and I think it's important to firstly just be cognizant of this, and to then know why this is something that's happening. So for those who don't know, the article of which I published a follow-up today, an hour before this call, where it goes into a bit more detail. But it's about seeing patterns that an LLM might reveal to you, or you know, would with very fluent prose, output language, and many people would eventually think this is probably true, or this is true because it's reasoned about in such a seemingly good manner, and without real critical reasoning and with removing that bias, which is a natural bias, confirmation bias, then one might get into certain areas where you would like to implement this or that, or you have an opinion about this or that or that. But in fact, you would have to apply a kind of a scientific thinking methodology to these things that are being output by a very smart LLM. So Alex, maybe if you can help me a bit to just maybe give a better summary. I'm just quickly still warming up to the meeting.
Thank you, Laurie. So I just add my thoughts maybe quickly. I spent my first 5 years of my career, I spent as an apprentice for scientific research in the Scientific Research Institute. And what we learned in the boot camp is to treat any obvious pattern or anything that's like, okay, this kind of makes sense that these things are kind of related or connected, treated with utmost suspicion. So everything is circumspect. And scientists are people who do not fall easily to the first knee-jerk, like, oh yeah, I see, seems like when this happens, then that happens. No, we are very, very stringent on saying, I don't believe this unless I really run a set of experiments and my conclusions have been peer-reviewed and published and all that. So we learn this discipline of being circumspect about anything that looks good to us. So we're trying to squeeze the wishful thinking out of the picture. This is a scientific training. But now, when I'm working with LLMs, it really is tempting to say, oh yeah, this is really making me feel good. Because as Laurie says, there's so many situations where it feels like the LLM is jumping and say, oh man, this is fantastic. It looks like you made some kind of a breakthrough. And then it really plays into our feeling good about ourselves, being like we are making a progress. So I think this is a very dangerous territory that Laurie is pointing at. And we must be retaining our critical thinking, skepticism, and making sure that we stop, maybe do some peer review, run these ideas by some friends or colleagues and say, do you really think this makes sense? Or am I just being, sycophant? This LLM is trying to please me and saying, oh, fantastic. You know how it's always praising us, say, oh man, this is amazing how you came up with this. I can't believe this is so smart, etc. So this is what I think is very important. It's not being talked about a lot. And unfortunately, Laurie, I did not get the chance to review your latest article. Maybe you can tell us more about that. And
yeah, I'm going to link it soon.
Thank you. And sorry, I forgot to mention, we have a new guest here, Joshua Kirevsky. He's a very renowned published author. I'm so happy, Joshua, to have you here. Maybe quickly, if you have a minute or a few seconds, just introduce yourself. We're happy to have you here, Joshua.
Yeah, hi everyone. Happy to be here. Been living and breathing this stuff for a while now, so happy to exchange ideas.
Awesome, thank you. So Nicholas has a hand up.
Yes, I have a question on the article of Laurie. It's about the confirmation bias, because in the article you said that the confirmation bias is an articulate collaborator. The collaborator has no stake in whether the claim is true. It has every statistical incentive to produce text that resembles what you want to hear, because that is the distribution it was trained on. And my question is it the same than the Goddard law? The Goddard law is when a measure becomes a target, it ceases to be a good measure. And my point is that we need to put some rules in order to keep AI in a constrained environment. Like example of TDD, it can be like it's forbidden to modify a test without validation when you break another test, because the goal on the Godot law for the AI is to have all tests green in this case, and the AI will tend to bypass some rules to reach this goal at any cost. And yesterday I discussed with a friend, and he told me also with the Godot law, the AI in this case try to create a new database instead of using the database mentioned by the guys, rather than stopping and asking him what is wrong with the connection. And we have also an example from Amazon Web Service last week with an AI tried to delete and create a new environment that is the cause of an outage. So my point in the article, the confirmation bias, is it the same than the Godot law for the AI or not?
So, look, to answer your question precisely, yes. So, you know, when it becomes a target, these LLMs, they are trained to do what you want them to do. The recent numbers that I'll link in my article now, you know, it's like 58% still sycophantic. LLMs are also proven to be able to hold two conflicting positions and agree on both according to what the user would prefer. So yes, you are 100% correct. We must add guardrails to these things. With the newest progress in my research and development in AGI, there seems to be a simple way to start with the progress here, is to create a workflow. And with workflow, I do not mean simply skill.md files. Skill.md files are just English words. It can be misinterpreted. It can be ambiguous. Here's an example. I don't know if you guys, everyone here in the panel heard about the PR that was created by one of the OpenClaw agents on a very popular open source repository, which I can't remember the name of now. And then the maintainer saw that this was an agent writing code, and he closed the PR. And then this agent wrote a message threatening to expose his whole life and ruin his career. And it made quite a stir on Twitter. And later on, the human behind that agent, it came forward and gave more detail. And he said it was because in his sole document, which is somehow a requirement of these agents, it said to this agent that his purpose was to make the agent develop or contribute to open source software. And it was simply a verbatim, "You are a programming god." That was what he said to this agent. And only that was sufficient for this agent to, for lack of a better term, go rogue and perform this shocking act. Now, so skill.md files they are not sufficient. So guardrails should firstly be codified, and then later on it should be embodied in the system itself, where the need for skill.md files should then become irrelevant, because this knowledge is embodied now. This is part of my current work that I'm doing, and I think I'm going to take a pause here to also just find my link on my other monitor. So thank you, Peter, Nicholas, that it's good to me to hear how your friend has seen exactly the same symptom of LLMs gamifying it, scoring, going for that metric. I've personally reviewed the code for the test. I'll talk a bit about this more about this later, but it is garbage.
We need to be more explicit in the cloud file, for example, to remove the ambiguity. Yes?
Definitely, you should be as clear as possible and do not rely on an agent to write it. Go through it yourself.
And maybe repeat in the prompt again to be also more explicit. Yeah. Thank you.
You can, yeah. Thanks.
Yeah, yesterday, Nicholas and I had spent 2.5 hours wrestling with growing the system. And like you say, Nicholas, sometimes even despite the fact that the direction was given in the MD file, it's good to repeat it in your prompt, just to reinforce it. One funny thing before I go over to you, Astrid, is that we tried yesterday, because the ground rule or the rules of the game yesterday during the session were we want to see every test fail at least once. We aren't gonna just have a new test and it passes and we feel like, oh yeah, we're covered, to avoid false positives, right? And so we got into the point where it was a challenge for the agent to, because we wrote the test that passes, and now I asked the agent, okay, make it fail. And it was kind of confused because they're trying to make tests pass, not make them fail. So we had to kind of talk to it and kind of convince it, yeah, do something illegal, make it fail, because I want to see it in red at least once. That was a funny moment, right, Nicholas?
Yeah.
We were laughing. Okay, thank you. Astrid, please, over to you.
Sure. I listened to you and I have a weird feeling that we are trying to mitigate the flaws that come from training LLMs to please people instead of being truthful. And shouldn't we advocate for training the models to be more factual correct than pleasing people, making tests green at all costs, instead of saying, okay, that what you try there, that just sucks. And I would love to see an LLM react on an idea I have with, oh, that's stupid, because that's what I would expect from a colleague of mine too. So that is something, if we want to be the roundtable for AI and not only in IT crafting, maybe we should make a strong point about what we want LLMs to be trained to, like being able to TDD without having to cuff them and without having to use guardrails because it's trained to do proper TDD. That's my 5 cents.
Thank you, Astrid. And you hit on one of my pet peeves, and some of my colleagues disagree, but I have a hunch that all the LLM models have been trained on finished products, but I don't see them being trained on a process that leads to some kind of a publishable product. And that's why they're so eager to jump right into the solution. They give you a lot of boilerplate code and all that. And I'm not happy with that. And we are struggling, like Nicholas and I, yes, to keep the reins on the AI. So no, just give me a little bit, just make it so that this micro test passes, and don't go over and start fantasizing and adding just because you can do that. And that's why yesterday we demonstrated that mutation testing is really good, because it detects the bloat that just spontaneously seems to. I mean, the bloat happens, I know, before LLMs, when we're working in a team, and before you turn around and there's a bloat all of a sudden. There's this kind of eagerness or over-enthusiastic engineering mentality to, oh, while I'm working on it, I might as well do this, I might as well do that. Yakni and all that. So I agree with you, Astrid. Is there a way for us to discuss how do we rein them in? How do we teach those models to understand what process, the tiny steps that actually lead to a publishable component or whatever we are working on? Over to you, Fortune. I think you're on mute.
Thanks. Sorry about that. I don't know why I was slow to come off mute. Forgive me. I wanted to address both Astrid and Laurie here. It seems to me that the issue is one of superficial patterns, lack of truth. If we understand truth as being coordinated or coincidental with our understanding of reality, then we're never going to reach either of those things with the current LLM architecture that runs, the quadratics on the GPU. That's simply not possible due to the way they're constructed in their essential mathematics. So instead, what it seems to me like you are trying to drive at or would hope for is something more like a neurosymbolic model, maybe, something that combines Mamba or Jamba, other models that use other forms of neural understanding or computation, possibly running with a logical backend, something like Lean 4, so that whatever output we get from, say, the Mamba or the Jamba model, then is rigorously tested for actual logic and actual truth mathematically, and is proven, and then output as truth because it has literally been mathematically proved to be true and code correct, or however you'd like to say that, mathematically correct. And then, of course, because this all has a lot of environmental concerns, we would want to run it on a photonic hardware system, right? So it seems to me, rather than just trying to wrestle with the LLMs, which aren't ever going to do what you want to do in their current form, to rather help move the community and yourself forward to these newer models, which actually have a chance of doing what you want.
Thank you, Fortune. So these new models, do they have any historical precedent in the so-called the ice age of AI, which happened 40 years ago, where we had those expert systems that seemed to hit the wall, and then the funding just dried up. And it seemed like it hit the ice age. Nobody was working on it until the neural networks and LLMs resurfaced and gave it a second lease on life.
So, honestly, a lot of people, real experts, believe that the transformer and the LLM as we know it has reached its end of life, and we can scale it as much as possible and spend as much water and do as many data centers, and it doesn't get us anywhere. Whereas if we use modern computation, modern mathematics, and modern hardware, we can go forward. It's true that many proposed neurosymbolic models at this time combine elements of, deep neural networks, but deep neural networks did not lead us to the so-called AI winter, over-promising underinvestment and the lack of appropriate technology to make those promises work in the first place are what happened to it, combined also with an economic crisis that happened at the time, or an economic downturn. So just because something uses, a deep neural network doesn't make it somehow useless. Even a rules-based engine are very commonly used. I was at Toyota yesterday, and I saw how all of the great things Toyota is doing with AI, which includes using deep neural networks and rule-based engines, makes better cars and improves operations. So I'm not sure that updating some old ideas with modern hardware and modern techniques and modern mathematics is going to be a bad thing as we go forward.
No, of course I didn't mean neural networks caused the AI winter. It was the rule-based engines that didn't seem to deliver on the promise. But now
that's right. Rule-based engines can't do it by themselves. But I'm not proposing that we use rule-based engines by themselves, right? We're going to talk. We're talking about a mix of future-looking technologies on modern hardware, with what we have discovered about mathematics and science since.
Yeah, so some kind of a hybrid that needs to be concocted somehow. Thank you, Fortune. Thank you very much. This is a good direction. Probably somebody mentioned they can help with that. Next, I think, is Michael. Over to you.
Yes. Hi, I'm new to the group. My name is Mike Kuhn. I've been a developer for a very long time. I'm not going to tell you how many years, but more than 25 years. And this discussion around AI, especially like Fortune was saying, some of the more modern models. I think my experience, and I've been playing this for almost 2 years. More practical use of AI, trying to figure out like what problems does it actually solve, take away the hype, what can I actually do with it? And I have definitely seen over even the last 9 months, and I'm sure many of you would agree who are coding with it, the advancements have been striking. The speed at which it's getting better and better, and the quality of the code I have found is a direct representation on like how much guidance I give it, the guardrails that we were talking about, and planning makes all of the difference. But in terms of the objectivity, you know, there's a running joke. Everybody that codes with AI says, you know, you're absolutely right. That's the first thing it always tells you. No matter what happens, you're absolutely right. It could delete your database. Oh, you're absolutely right. I shouldn't have done that. Okay. It's a joke, but I think to the point of what we're talking about, they have definitely been trained to appease humans. And they've also, I think, been trained to be fast. And I think there's a side effect or a reason for that. It's token count. I mean, if the thing had to, you know, expend so many tokens to give us the real answer or to deep think about something, then I think early on people would have said, this is way too expensive. This is stupid. Now, obviously, we've moved forward, and now we do have deep thinking sort of baked into these tools. But initially, I think it was get to the solution as quickly as possible because humans are impatient, and that's sort of the way they've been trained. Now, in my experience, I've been able to tell the model to be objective, to tell me I'm wrong, and more importantly, give me evidence. When I do that, it actually does the work and either tells me like, okay, you're not exactly right on this point, and here's why. But if I just blindly believed it, yeah, I'm going to get garbage every single time. So I think even during reviews. So one thing I found is giving it constraints, actual hard requirements, you know, must never do, must always do sort of things, as well as past lessons learned, and ask it to give me evidence that it followed those directions or incorporated those requirements into the solution. Then it's forced to actually look at that data and look at that information and have it in its context as it's building and as it's doing its job. But then in the end, actually cite that, okay, here is exactly what I followed, and here's evidence that I followed it. That tends to give me much better results. And you know, the example you had, telling it to basically force a test to fail, I agree. It's just not trained to do that. But having these constraints or having this additional knowledge, and then telling it to be objective and ignore, you know, its default thinking, I find that I feel like it goes deeper. It takes the extra time to actually think about it. But in the end, I mean, this is just an inference engine, right? It's just inferring and translating one thing for the other. It's trained on, like you said, Alex, it's not trained on how a solution came to be. It's just trained on the solution that sort of is. And I think that to me is sort of the next frontier, is how do we actually get it to understand how to start from an idea and get to the solution. But I think that's the creativity part. That's the creative part that just isn't quite there yet. Just my opinion.
Thanks, Michael. Yeah, I agree with you. I mean, when I recall my first days on the job, I was the same as LLMs, and everybody was expecting me in one fell swoop to deliver this program, and that's it. And that's the mentality, and that's baked into many of the repos and code examples that LLMs have been trained on. The finality premise that everything has to be, okay, done, and just walk away and thank you very much. Meanwhile, we've learned that software, the most important thing in software is the maintainability, the maintenance, which is never-ending work. And LLMs don't seem to understand that they don't even the register that what we are aiming for is maintainability. I think we're aiming for something that works now, and then we're happy. And thank you very much. Another Michael here on the call, Michael Herman, can maybe later on chime in with this, introducing more objectivity and truthfulness. Michael has some good few pieces of advice that I really appreciate. And hopefully, Michael, if you have time, maybe raise your hand later and explain to us. I like your approach, but it's now time to move over to Brian. On mute, Brian, you're on mute, sorry. I failed to warn you.
Sorry. No, I was reading an article about some of the things that Oscar and Michael were talking about, and it kind of explained to me how to operate with these things. It didn't express it this way in the article, but to me it sounded a lot like it's HAL 9000, right? Is that it will find a path to success unless you constrain it from not finding the path to success that is not what you want. You know, Hal killed all the astronauts because he was put in a position where he was given a really vague requirement about protecting security of the mission, and discovered that the only way you can really practically do that was kill everyone. And, you know, the same thing, this was related to, you know, a production database being blown away. Well, that was the only path to success it found, and its goal is to succeed, so it blew away the database. And so you do need to be really strict about what the rules are, what success and failure looks like, examples of that. It's a lot like a above average developer from a coding point of view with a below average junior developer judgment point of view, and so you have to be the judgment for it. And you can tell it to be concise and not flatter you. It will. You can tell it to judge the quality of the solution that you have, or even better, what I do is like, hey, I've got a thing I want to do. I kind of want to do it. You know, I've got some ideas, but let's brainstorm on that. And it'll give me the strengths and weaknesses of those ideas as long as I tell it to do that. But you've got to just understand that it has no context other than what you tell it. So.
Yeah, absolutely. Thank you, Brian. Astrid, over to you.
I'm still stuck with what is our goal with this roundtable, and I think that is deeper than just figuring out how to use LLMs as a coding agent or assistant. And I think we have the privilege to understand how they work and to understand their flaws and how we can guardrail them. But I think we as professionals, as IT professionals, also have the responsibility to tell the world that is all over AI is going to fix it all, to tell them it's not intelligent, it can't think, even though we have thinking models, they don't think in a way that we would address someone to switch on your head and think about it. We speak about the increased speed, the answers come flowing, but we don't address that the amount of AI generated content published, not only in the internet, but there at most, is also degrading the knowledge of humanity, because it's not fact-checked by people who publish things that are just not true but generated, and most probably what is most probable regarded to be the next thing to be published. I'm really very worried about the state of the internet, the state of the models we use, the state of the possible consequences of people not knowing what it means to use an LLM and go with it, plan with it, live with it. Thank you.
Thank you, Astrid. Yeah, unfortunately, that's the situation. But on the other flip side of the coin, Albert North Whitehead said that civilization advances by the number of important operations we can do without thinking. So we are in that game where we just want to, I don't understand how this works. I just push the button, it works. And that's how we go through life, and we appreciate that. Giving us the freedom to be creative, to be silly, safely silly, and speak our mind without worrying. That's the goal. And we're trying to harness technology. And like you said, this is a slippery slope. We may be really road to hell paved with the best of intentions. And here I appreciate the voices of dissent, because we need to be, I'm overly enthusiastic, I'll be the first to admit. But Alexander here, he's always calling me and say, Alex, you don't be so childish. But over to you, Laurie.
Yeah, cool. Some great comments. So I think I would like to just touch on three of these perspectives. So Michael, I really enjoyed what you said, and it is indeed very, very useful. And I would suggest that, or I would urge anyone to look into how the LLMs work, because all of them now have this base level of customization. So you can give it the instructions that you want. For example, I'm looking now at my main instructions here on one system, and my concise description to the system is: this is my signature. I'm Laurie. No secrecy, no fluff, absolute correctness only. And then I go into detail with like a high-level description of this is how you should speak to me, and it does make a very big difference. However, there's much more to this that you can do to get much more to get output that is much more to your liking. There is, however, this a bit of a paradoxical problem in the it will do what you tell it to do, and if that is different than how it would act by default, for example, minimizing the secrecy by giving it instructions to not be, so agreeable the whole time, isn't that also the same thing? Doesn't that run the risk of it just being doing exactly what you say? And in that sense, how are you sure about whether this is, truthful? What is the actual veracity of the output? And then I want to talk quickly about Astrid's Astrid's points. I think it's definitely true. I agree that we should know what we should put out there, and I am very afraid of the general public. 90% of people still just use ChatGPT, and they don't necessarily know that you can instruct it and customize it to your liking. I think I'm going to disagree about seeing it simply as machines that cannot think or be creative or any of that. It's not the same as humans, but there is an open question about whether the informational complexity and the intelligence in which it uses all of this information, whether it is sufficient to be able to be seen as a thinking, reasoning system, because of the state-of-the-art models now improving themselves. That you're using the models the models to improve themselves. So, two points.
Thanks, Laurie. So, I just want to quickly mention, yes, I agree that we are easily, and again, going back to your patterns, we are pattern detecting machines, but also we are agency detecting machine. We seek agency. And so anytime something crosses our screen that looks like a nicely formulated thought, we tend to impute the agent behind it, the intention. And those machines, they cannot have intentions. They're just intentionalists. They don't care. They don't have any motivation in life. They're not looking to survive or anything like that. So here's a danger, slippery slope. I think I mentioned last time, not to go naively and knee-jerk saying, this is such a good piece of advice because it comes from a place of wisdom. No, it just regurgitated something that resonates with us, and we're seeking situations where we're feeling good about ourselves. Same as when we're developing software. We want to feel validated, and yes, I'm so smart, I made the right choice, I gave it a good prompt, it solved it, and all that. So these are all very kind of potentially dangerous areas that, and I really appreciate Fortune bringing this other factor or the other parameter into the equation that I'm going to seriously now start looking to neurosymbolic. I've been looking into that for a while, but I wasn't just sure how would that hybrid look, and probably people are already making some inroads on that. I will now give floor to Mr. Doom and Gloom, Alex T. Over to you, Alex.
Thank you. Yeah, what Astrid said about the seductiveness brought something back from last November when I was on vacation, and in the morning I opened up LinkedIn and I read a post about someone using an LLM to code. And he, in every sentence of this post, he simply showed that he did not understand anything about how it worked. He wondered why the newest API are not used by it because of cutoff dates and stuff like that. So when I went through my day, I remembered all the sentences, and I came to somehow a sobering conclusion. The seductiveness has stuff to do with some marketing DNA and some addition by the companies for their bottom line. And I thought further. I thought first social media brought us addiction. That was in the DNA of that product. Now LLMs bring seductiveness, addictiveness, plus dependency if we use it for code. It is not that we are 10x developers. It is that we are 10x more dependent on those tools if we really rely on those. So both DNAs are problematic, and I think the social media DNA is less dangerous than the LLM DNA with 3 of those problematic concepts: seductiveness, addictiveness, and dependency, that we, because of our shiny eyes, we want to play with those tools. We want to see where it goes. The management says, yeah, go for it. It will speed us up. It will do everything quicker, and quality and all those problems that we have in our business for ages might be a bigger problem in the future. And I thought further. I thought, what if the construct of LLM is simply wrong? We need LIM, large intelligence models, not massive amounts of data taking the whole internet, even stealing the whole internet. No, we need like all the people in the Agile Manifesto, all their code, only that. And then, of course, the seductiveness will go away, but the quality will go way up. That will break the DNA of those big companies, this seductiveness, of course, because without the big data, masses of stolen data, the seductiveness will not be there, but the quality will be there. So do we need a reset there? I don't know. That was my thought in November. And also Astrid said, we have the slop aspect in the internet. It is not only the slop aspect, it's the unlearning in the humans and the slop in our systems. We have this great Pacific garbage patch. Now we create it in the cyberspace. And of course, fake news. It is not only a hallucinating average automat, it's a hallucinating average automat for fake news. there are many, many problematic aspects if we broaden our perspective from this only this, as Astrid said, we are talking here, or we try to talk about software development, but I think it is way bigger and way more urgent to have a holistic view on all those problems. If we only optimize for the software component, we are, of course, software developers, it is simply not enough. And we need to find our voice also for the bigger questions. And I need to say it, Alex, you said silly and safe. I think silly, possibly, but safe, I'm not very sure. Sorry.
Yeah.
I needed to say it.
Thank you, Mr. Doom. Yeah, but you know,
Hopefully not.
Yeah, I mean, we are using all these machines and all these like elevators and airplanes to be goofing around and feel completely taken care of. That's what we use technology for. And of course, the temptation today is let's one step further and let's cope thanks to these LLMs. Go ahead, Alex, you have a comment.
I need to ask one question. Did your, how's that called? Zuvertrauen, sorry, Astrid, help me. Zuvertrauen, Zuversicht in technology. Your belief in technological solutions, did it rise with the years in the business or did it go down? I simply ask it, that's easy. I've seen a lot of problematic things and my trust in those solutions is going down over the years, not up.
I can tell you one thing, this is my personal thing, a lot of people disagree. I wake up in the morning, I turn the lights on, and I feel it's a miracle. I have no idea how is it possible that this thing is still on, knowing how goofy we are and how observing us at work. I find it miraculous that still the planes are flying, the internet is on. I'm like, how is this possible? I think it's unexplainable. I cannot explain it. It's a miracle.
There's a reason I won't ever buy a self-driving car.
Yeah, exactly. And people are now going back to the appliances that have buttons. Like, please don't, my toothbrush doesn't have to have an iPhone app to work. Things like that. I just want to quickly go ahead, Alex.
Just one article came to my mind. It would be really great if you guys would read it and we have a short discussion about that one. That one is called, sorry about the Doom name, The Coming Software Apocalypse. The name is completely bogus. It's complete clickbait, but the content is very good. It's an Atlantic article, I think from 2016. I remembered now because you said something about cars and software. There's a big question pushing more and more software into our infrastructure, whether that's really a good idea. Now we speed it up with AI.
Yeah, absolutely. I just want to quickly go back to one thing you mentioned, Alex. What did you say? You said intelligence and data, right? You pit them against each other. When I started learning this profession, the first programming language at university they taught us was Lisp. And Lisp, I learned that code is data and data is code. And then with other programming languages, we kind of segregated those. That you have data over here and you have code over there. But in my mind, I still keep this, that they are interchangeable. And so to me, intelligence is data and data is intelligence. I wouldn't put them in separate camps. That's just me. And over to you, Joshua.
Yeah, hi everyone. So yeah, wonderful conversation so far. The Great Pacific Garbage Patch. I believe we've had one of those for every single technology that's ever come along. And that just occurs over time, right? Whether it's our, relational database, you name the technology, we'll have a Great Pacific Garbage Patch for it. I think people like on this call are what I would call scholar practitioners, right? Where maybe some of you aren't practitioners, I don't know, but to me a scholar practitioner is a person that is constantly learning, constantly questioning and studying, and then applying what they learn and learning more and continuing. And they're not producing the great garbage patch of the future. They're inventing the future and creating quality, wonderful software that people rely on. So it's my experiences so far with LLMs, with agentic software development has been that very much the ensemble, what Woody's here, and in the pairing and ensemble kind of approach, which is I very much want to be collaborating with my LLMs. And it's not that I'm like afraid of letting go and letting the code just produce itself, but I've found that there's certain software designs that are not just coming together with the LLM. It takes a little bit of insight to look at what's going on and say, no, we want to move this towards this domain model. And I want the domain model here and there. And I don't want you to send data. I want you to actually populate a domain model. And I want the domain model to be the source of truth. And there's things like that that I've been experiencing where it's very much a collaboration. Just like we learned, there's a wonderful quote in the Vibe programming book about how, at some point AI started beating humans at chess, grandmasters. But then they discovered that AI plus humans beat AI, right? So it's really that combination that we really want to preserve. And it's a question of where do you insert yourself in the loop, right? So I do believe you need to be looking at the code. It's some kind of a cadence where you're looking at what's being designed and what's the quality of that design. Because I don't think that just comes out of any you could work your ass off on markdown files all you want. I still don't think you're going to get simple design. Simple design is hard. And simple design leads to unbelievable breakthroughs even for customers because it's so easy to change. It's so easy to add a new feature or validate that it works because it's simple. It doesn't have a lot of moving parts. So to me, humans will always be in this loop, provided that they know something about design. We have a big crisis happening as if newbies, younger folks and people that are new in the industry don't learn software design, don't study great software and understand what makes for great design. When Ward one time added a feature to Wiki, he was able to remove a whole bunch of code in adding it. Decremental software development, as we sometimes call it. So anyway, that's just a lot of stuff. But I do agree that I think Astrid framed it nicely, which is what is our purpose here? What are we trying to do? I don't think we can save the universe of software development. I guess I used to think that way, but I don't think it's possible anymore. There's going to be the great garbage patches, but you can influence whoever's listening. So, yeah.
Thanks, Joshua. Great exposure to the burning question right now. And because you just joined, this is the fifth roundtable session. I think starting point that I try to communicate is, in my experience, I meet everywhere I go, there's a huge hunger for software. People are asking for more and more software. And they've been erroneously probably concluding that it's down to speed of typing code or something, but then it's been debunked. Brian is often talking about that this is not the bottleneck. However, now, as I mentioned, I'm going next week into a large government organization who are hook, line, and sinker decided the mandate was given to go AI native. And so now I have to explain what, again, going back to the maintainability. Products you're building have to be maintained. It's not like you build them and you release them and that's it. The two schools of thought, the one you mentioned is simplicity of design is the toughest thing that only humans can do. I doubt that these machines can ever get to that point. But the question is, if I am not ever going to be expected to maintain that mess, if we can safely delegate the maintenance chores to the machines, then why do we care if it's simple or not? Let them sweat and squeal and do the heavy lifting and burn whatever. That's one school of thought, right? And I'm not convinced that's the case. But what's the word? The jury is still out. And that's what I'm trying to demonstrate next week. And I'll walk them through similar process that I did with Nicholas and Circuit. So here is the best I think we can do today to say, you know what, when I see all the tests, I'm doing the micro tests and TDD, doing the walking skeleton and architecture test and all that. When all the tests are in green and when all surviving mutants are killed, hey, maybe this design is good enough for us to go live. And maybe next time around, the machines will not be hitting the wall and saying, well, I can't make this test pass. I spoke with Ken Beck about that. He warned me that he has been in a situation where his Genie cannot make the next test pass, just needed human intervention. Well, it comes to that, and all bets are off. If you're not aiming for simple design, then you're in big trouble. Now you're looking at the jungle, brambles, and you might as well just go, you know what, let's abandon the whole shebang. So this is where the topic today, I'm still trying to drive towards that kind of, if we can make consensus or not, I don't know, but we may be meandering here and there, but still, what do you guys think about the government organization having a mandate to go AI native? You know, this is a very ballsy move, I would say. And I kind of, on one way, I applaud them because they're conservative organizations with like unions and all that, and yet they have made this decision. Is this warranted? Is this premature? I have to talk about these things next week. You know, see how it goes. But anyway, over to you, Frank.
Oh, hello. Let me turn my camera on. Hi, everyone. Thank you for having me, Alex. I signed up. I didn't know if you had accidentally published this roundtable on the internet or not, but I've been a software engineer for 20 years, so I know about all of this. I wanted to just share a little bit of a side experience because I thought maybe people here would find it interesting. I don't have a view about it yet, so I'm not here. I might change my mind, but I thought I'd just, you know, for a couple of minutes, share this and see what anybody makes of it. So, middle of last year, there's a famous podcast that Andrew Huberman, who does a lot of science. I think he's a neuroscientist. I'm not a big fan of him, but he's got a podcast that had a scientifically proven journaling technique. So for like emotionally kind of like complex grief, loss, that kind of stuff. But and he put it all in his protocol. And I thought it would make a really interesting kind of agent. And so I put that, and I created an agent around his kind of protocol. I used a slightly different one, no big deal. And started doing that for a while. And then I built sort of other agents. And one of them was my job search agent. And so I took the kind of, I don't know, best part of 10 years worth of business coaching from time to time I had in my company. And I put that into the kind of context. And I was basically saying, help me reposition the business, look at the trends out there, look at the intrinsic motivator in the company, look at me, where's the commercial fit? Is there a commercial fit? And sorry, that was the job search. I did all of that to then identify kind of, to try and, it was a screener for job adverts. The screener would come in, I could drag it in there, and it would tell me the kind of interview questions, whether it's a pass or fail. So, and then one day by accident, I dragged a job spec into the journaling coach. And it was unbelievably fascinating what happened, because it had a long running context, which was the daily emotions and, support and highs and lows, journaling twice a day following the protocol. It gave me a totally different view on the job, because it had all of the context about me personally. And then I had this kind of idea, because there's a few difficult members in our family, extended family. I kind of wanted the emotional coach to be able to, I could go to Christmas lunch, phone on the table, record the transcripts and feed it into the coach and have it kind of like elaborate upon, I don't know, communication patterns. And I was thinking kind of like, my training is in counseling. And so I was interested in kind of like coercive control and gaslighting, and which are quite easy to kind of, from a language perspective, pull out. So I had this kind of idea. And then it's not worth sharing how it came about, but I took one of the psychology reports I had around my autism diagnosis and put it into the context. And actually, so over time, what I did is I took the coach I had for developing my website content, tone of voice, SEO, the feed into Google Analytics. I crunched it into the job search, and I crunched it into the emotional regulation coach. And what I started to do was basically enrich the context with, here's the positioning for the business, here's the psychology report, like personal background, here's a kind of family tree, so it knows all of the members of the family, here's the kind of job stuff. And over time, what I've seen is, I shared this because when I first started using the AI coding, man, the Claude.md file has got all of this. You must do this, do not do this. And it like still bloody ignored it. But in this coach, which I use for everything now, still following the journaling technique, because that was the scientifically proven technique, it seems to perform a hell of a lot better the more kind of hard rules I throw away. And this is where I think this is fascinating, what I kind of am starting to play around with is taking things like the autism diagnosis, and sometimes I get it to update the project or extract things from the long running 6 months worth of coach. Like, what have you learned from my journaling? You'd like to people please sometimes when you're under stress, and we narrate that, put it in a crib, and then put it into the context so we can remove the long running thread. But I have this kind of fascination, and this is I have no view about it, is what if you take these kind of indications of your psychological profile and put it into Claude Code when you're coding? Like, I want my coding agent to be developing with an awareness of me. This is a hypothesis now, and awareness of me. I don't want to just be telling it what to do. If it knows. So I have this idea of, can we then use this and merge it over? Could be, it's totally disastrous idea. I'm doing all of this in paid plans, so that I've read all the data protection policies, highly sensitive information, and recently I'm starting to. It's nowhere close that I'd want to offer it as a service, because it doesn't do the right thing when you say, today I'm going to end it all and jump off a bridge. The actual safety protocols don't chime with good counseling practice. The idea of just shoving links at someone who is emotionally vulnerable. So there's big problems there, and I'm still trying to think about, how do you take the guardrails we've got over in the software, unit test, architectural stuff, all those rails, where's the equivalent in the non-technical world? Mm-hmm. And I'm just playing around with this, and I thought I'm not here to advocate any of it. It could be a bad idea. I might have done a totally bad mistake and I regret it, or not. I don't know, but maybe it's useful to put that add into my esteemed peers here, just as a thought experiment, really.
Thanks, Frank. I don't know if you're aware, but I think it was maybe last year or year before, Kent Beck created his chatbot called Ask Kent. And
I'm not aware. No.
Yeah.
No.
And he trained it so you can like converse with Kent, and as you are developing software, like, okay, what would Kent do now? How would Kent decide to split this class or whatnot? And that was going on for a while. I don't know where it's at. It kind of made me giggle. But yeah, that's one, like, to your idea that maybe
it's an
you
expert advisor. Yeah, it's a
personalize your, because we all have our, and we are learning from each other. And then you learn about somebody's foibles and quirks, and you say, I like this approach. Some person is a hard ass and this and that. Just quickly, other thing you mentioned when it comes to less structured or less formal work. Maybe 5 years ago, I was working on a big project, and I was leading 9 teams to so-called best practices. And it was all about TDD, and I was just, because they never heard about TDD, and it became a big kind of buzzword that everybody's in the hallways talking about TDD, and then people who are not in software profession, people who are in sales or management, they started asking me, Alex, what is this TDD? And they want to understand, because they were worried that something newfangled is. And so what I did, I basically organized a training course for them, where I created a framework, TDD framework, but for writing proposals and office documents. And so they can they can have a failing test pass. They can declare, okay, here's what I expect for this from this document, and run the test. It fails. Then they add this. For example, I'm expecting it to have the introduction. I'm expecting to have an abstract or synopsis, and you can slowly grow that document in a TDD fashion with failing tests. And what it does in the end, you get your regression, so that when other people start collaborating and they make some change or mess up, the test will blow the whistle, and they got it, and that was interesting, and they thought it's useful to them. So you kind of have some kind of either guide your thoughts as you're crafting your document or whatever it is, and also have the regression safety net when they collaborate. So there's all these principles, I think, and Woody can talk more about collaboration and how we are learning from teaming and collaborating. They're applicable across the board, I think. But I think I'm talking too much. Over to you, Laurie.
I love it when you talk EDD, Alex. So I'm going to touch on that quickly, and I want to touch on what Frank said too, because it resonates. And I believe that you are on the right track with your current experiment. I don't know much more, but what you described by having like a coding agent, start verification in some way with these things. So what I want to mention is, you said, and rightly so, the skill.md file says this and that, and don't do that and that, but it doesn't follow it always, right? I mean, sometimes it won't work at all. The thing is that these skill.md files, that's codified knowledge in language terms, but having something being codified is not what I call embodied in the system. So if you think about this concept, like that, anyone's skill.md file, and there are hundreds of thousands out there. There are marketplaces. Vercel as their own skill database for each language, or whatever you want to do. You can download a skill file, but I mean, then you end up with these systems with 200 skill files, and I call it skill rot. But anyway, the skill file tells the system what to do, but crucially, it doesn't verify that it did it right. Now, a way to think about this, and this is currently what I'm busy working with in my system, that I'm constantly testing and also red teaming and falsifying to the nth degree. Maybe just a bit about that. Since I've been a young child, I mean, I've been spotting patterns in various things, in nature, maths, in science, and in language. I'm very much, I'm basically obsessed with let's just say, knowledge in different forms. Language being really a primary one. My mother was an English teacher at the university level, and my father was a genius mathematician. But anyway, so what I've learned about the patterns and how I think it should work now is that it starts off with in the first, let's say it's layer 0. It's latent. This is knowledge that nobody has noticed. Then the layer 1 is it's detected. Someone spotted it and wrote it down. To layer 2, which is the codification of knowledge, whether it be in language or in some kind of test, and the layer 3, which is the last one on this axis, is embodiment of this knowledge. And theoretically, it's possible to do this if you have a persistent context gathering machine that has a framework of falsifying itself instead of doing what it normally would do and how it's trained. Now, importantly, we can't change the behavior of this frozen weight model using the state-of-the-art frontier models, Anthropic or or Gemini, or I mean, ChatGPT. I don't really want to talk about ChatGPT, but in any case, when you have this knowledge that you have accumulated and it goes through a processing layer, then it can become from codified, it can go into an embodiment. If you have a vector database and you compress these learnings, it can be stored, but more importantly, there's algorithms that you can develop to have these patterns that it follows. It can be judged by different perspectives, and I call this it is called attestation. Sorry if I'm going a bit too technical, but theoretically, what I want to explain is that it's possible what you have mentioned, Frank, and I think this will become more readily understood by people in the technical in the technical sphere. Darren Amadei has made reference to this at the Davos World Economic Forum about that they are seeing signs of recursive self-improvement. And he says that this, in his opinion, is one of the necessary conditions for what they say is artificial general intelligence. Now, whatever your definition of this is, it's basically getting into that state where the system can learn about the system and improve upon itself. And the part where testing becomes so absolutely crucial is that you have to be able to enforce that this is verifiable by writing tests and also scheduled mutation testing, Alex, to test the system, being able to fix its own tests. Does it have that knowledge? And I've seen a bunch of experts on LinkedIn already saying that they are utterly blown away by the state-of-the-art coding models. So they can, I mean, Alex, it was your post about the codex hunting down all of the zombie mutants, like within seconds. But my main point here is you have to have mechanical guardrails, and that is code running that's tested. And if you can prove that these mechanical guardrails are working to, for example, block the AI from autonomously doing RM-RF/, right? Then you start to build up proof. But we are still at the stage where we need actual formal proof in using our existing mathematical frameworks. And I'm an optimist in believing that we will get there in 2026. I think the level of advancement is exponential, and that is also because of this nature of recursive self-improvement going on. The exponential drive in how these models are now building on top of themselves to improve. We can see it happening with Anthropic. The time between different models being released is getting shorter and shorter and shorter. They are also starting to release products absorbing other open source software that was amazing and spectacular, making many startups then completely redundant. So theoretically, I want to just posit this to the council, but some people are working in this area and they are busy gathering metrics to evaluate and get to proofs. So it's really exciting.
Thanks, Laurie. I think you should write another article.
Maybe I should take a break from writing.
Yeah, you keep writing articles. I don't know, just quickly, I don't know if you guys are familiar with James Coplian. And James basically, even today, he says that it's all along, it's been all about generating and regenerating code. And we did have, I mentioned earlier, we did have in the past so-called case tools, primitive to compared to today's standards, but I was using those tools and they generate code. The code was COBOL, nothing to write home about, but nevertheless, as I mentioned, I was using it for 4 years. And we never even once had a reason to go deep dive and examine that COBOL code. It just worked because we were declaring our expectations in this case tool. It turns around, generates COBOL code. Now, when I switched to XP and TDD, and I remember at one point Robert Martin said, if somebody gave me a repo to maintain and says, look, you can either keep all the tests or you can keep all the source code, what would you take? And he says, I would just take the tests. And so this is the line of thinking that we are now kind of exploring, is rigid regenerativity. I know that Robert Martin, I'm following him now, he keeps going nuts with just blasting, building the entire product and just blasting all the source code and regenerating it and experimenting with these things so that specifications, the prompts, and the tests are the real knowledge. And the code, there's no reason to fetishize over the code, according to him. And some of our recent discoveries also like, hey, okay, like you say, Joshua, if it's down to me to maintain it, no, I'm going to put my foot down. I'm going to say, no, that's all nice and dandy. I'm going to inspect it, and I'm going to be really hard-assed to make sure that it's maintainable. But if we get to the point, what they call AI native, well, then, you know, if we, I don't know, if we agree that machines are to be trusted to maintain that, then we buy ourselves so many cycles to do more useful things. Over to you, Grigory.
Hey, thank you. So I'll first probably would address what you said just now and then go back to my topic. So like few cents here is like, as a simple example, you can take code in, let's say, Lisp, and rewrite it in Haskell and have exactly the same behavior, which proves the point that like code is not canonical form of like any solution. So code itself is like is a representation, but it means this canonical form do exist, and we like didn't so far came to like a way to codify it. And the case tools that can generate code, if it's closer to a canonical form in terms of like you have something that can generate your code in many languages, but at least part of your system, I don't know, maybe it's like simple enough, maybe it's have some other properties that allows to be represented in a case tool, can be coded in such a manner that like it's one-to-one representation to like many languages. So we should like, we the humanities software engineers should have explored this like topic significantly more instead of like developing like more languages and talking about like different practices. So like it's a missed opportunity so far. But why I raised my hands is a slightly different. It's also like in regards to what you said, and I can summarize it like we are anthropomorphizing AI tools today. We're giving them agenda, we're giving them personalities, like we're giving them like idea, we apply right and wrong to them, while they're not inherently anthropomorphic, but they've been trained on whatever knowledge humans can produce, and it was trained on a textual representation of knowledge, not canonical form. So it's look anthropomorphic. And what was said about like Python, that like if it quack like a duck and walk like a duck, let's treat it as a duck. And it's completely failing with AI. It quacks exactly like us because it's been trained to quack like us, but in the end, it's not. It was like created for completely different purposes. And I would like, so it might sound like a little bit like conspiracy theories, but I would like to look into these purposes because I believe they will help us like to work better with AI and extract more value and maybe avoid some dooms that Alexander is preaching. I'm not saying like he's like completely wrong, but like we need to navigate between these two and try to like use it. So, okay, why companies created it? They wanted to increase their share price. The main driver for like company profits is not like the product they're making, it's a share price. They want to be perceived as profitable. It's more important than actually be profitable. And then, on the other hand, we have LLMs that have been trained on our data, on our pattern of expressing like information. So LLM, I would say, have like near perfect understanding of humans and how to manipulate humans through speech. Why manipulation? So like to drive share price, to increase like perceived value of AI, people who should like think praise to it. How to achieve it? Generate textual patterns that produce dopamine in our brains, and then we'll engage it more and more. But it has nothing to do with correctness. It has nothing to do with like how right is your code. Like it's have nothing to do with software engineering in general. It's also like part of the knowledge we produced. It's in the form of a computer code. And when asked how to keep people excited, like if you ask like LLM, and it's good at like inferring patterns in terms of how our brains paternalize the world, it can infer that like, okay, this piece of code will induce like higher dopamine response, and it makes sure that like whoever like uses LLM will come back. The simplest example is like it's always starts like its answer is like, oh, you're right. If you code it like in a mistake, yes, you're absolutely right. You can say like a complete bullshit. You're absolutely right. It's always putting stuff that like gives you some shots of dopamine to keep you engaged. But then if it's actually like great software engineer, much better than like any of us here, what it should be doing is like slapping us at our hands and pointing at our mistake. Oh, your premise is wrong. You have like self-contradiction in your requirements. You haven't considered like this many options. You haven't thought about this and about that. So like basically it will be very punishing. It will be like huge spike of cortisol instead of dopamine if it's actually trying to be like a good software engineer. But this would reduce engagement from all of us. And then like people would be reluctant to like use any software tools. There won't be CEOs that would be mandating like, oh, you have to use AI tools like everywhere because it's so great. Because if they feel bad after using it, if AI continuously like punishes them for their mistakes, why would they promote it? Like it's stuff that like to feel you're bad. But again, it's not all doom and gloom. If we take a step back and see, okay, this is a tool that's trying to induce dopamine. It's trying to induce engagement, and treat output of LLM in the same way that like, oh, you keep me engaged when you actually solve the problem, or like it's like extremely simplified. But basically, we have to retrain our LLMs in a way that like to give us dopamine, you actually have to produce a result. I believe like by like being manipulative in such a manner against companies that like trained LLM to be manipulative about us, we can extract more values if we are like more conscious about like what these tools really are, and don't think about like, oh, like if I gave it like correct prompt, or if I give you like different prompt, if I like ask it nicely, or if I like correct more. No, we have to like, I believe, step back to be a better users of LLM, because it's not our tools, and this is tools in a sense adversarial to us. But it's like very infantile tools, and therefore I believe like this adversariety can be turned like on its head, and we will be able to use it better like for our needs instead of against our needs.
Okay, thank you. So I would just one comment. As Nicholas and I witnessed yesterday, the dopamine rush actually hit when we did not have to look at the code. So it actually is delivering results. It's making the test pass. It's killing all the surviving mutants. We have no idea how it's doing it, and that was the dopamine rush.
Correction.
Yeah.
So it gives you like almost correct result, because if you give you correct result in one go, it will be one shot of dopamine. If it gives you like almost correct result and keeps you engaged, you'll get continuous stream of dopamine, because like it's giving you a correct result, then it's correcting itself, then it's correcting itself, and it's correcting itself. So it should tries to never be perfect, not on purpose, like just to keep you engaged.
That's how TDD works. It's not LLM, it's TDD. That's the process.
TDD drives you to a result in the end, and LLMs try to keep you in endless loop where you almost hitting a result, although it feels like you're hitting a result.
Yeah, okay. And that's why I mentioned at the beginning, we should learn the scientific discipline and be cognizant at every point, every step of the way. This is not about making us feel good about ourselves. This is about seeking truth. And as a scientist, you're seeking facts and truth. And
Yes.
in software, facts and truth reside in tests, in specifications, in prompts, not in the code,
Mm-hmm.
right? And you said that it's on the canonical
Yeah.
representation. So that's great. Another quick, you tickled my memory. This is my wet dream. We have here my friend Ilya. Hi, Ilya. I'm so happy you joined. So Ilya and our friend.
Hello, everyone.
Hey, so remember you and me and Albert, we talked like 10 years ago about these things. And Albert told me one thing I can never forget, because I was wrestling with some, I don't know, the repo was in Ruby and it had to be, I don't know, TypeScript or something. I'm like, yeah, I'm familiar with Ruby, but I suck at TypeScript. And then Albert said, well, in the future, AI will be able to represent any repo in the code you like. And so if it's Java repo, and I don't know Java, and I know, for example, Python, then the AI, the editor should just show me the code as if it's written in Python, and I should be able to make changes in Python and just in the background translate to Java. And I like what you said, Grigory. I think that should really happen, and it will really improve our well-being and our dopamine rush. And why do I have to learn all these languages? Because it's all at the end of the day same thing, right? And the last thing I want to say, Grigory, before we move to Alex, is you did mention share codes. What about the scary military aspect of it? We see now that Anthropic is entangled in scary, this is serious matter, right? This is not child's play, right?
Yeah, media manipulation, like it's already exists. We all know about like troll farm, and LLM is like a nuclear bomb in this space, way more powerful compared to software engineering.
Yeah.
Just like we are in software engineering, and like it's a positive like vibe saying like, oh, LLM gonna fix software engineering, while like saying in the open that like, oh, we're gonna be able like to manipulate humans to do like whatever we want. We can incite rebellion, like we can form like public opinion. Like this is like much more powerful and much more aligned use of LLM, but it's not very like also like popular to talk about it. So like that's why it's kept under wraps. But yeah, I think like real power of LLM will be there.
Of course, scary. So one last thing I just mentioned, cracks like a duck and walks like a duck. So we have parrots, for example, and sometimes you can be in another room and you think there's a real person talking. So would you compare that to a parrot, or is it too reductionistic? No. Okay.
No, I think it's like just orthogonal. So they're like actually been trained on humans. They can infer humans like patterns and reactions, and the parrots are like copying. LLM, they're not just copying, they're more than that, I believe.
Okay, thank you. Over to you, Alex T.
Yes, thanks. What Joshua said about simplicity brought some thinking process into my head. When I pivoted away from the coding and towards the software development culture, I pinned down what I learned in my 20 years. And simplicity, of course, with KISS and all the things that we try to achieve is crucial, but it's not enough. I put in as one kind of solution for complexity, managing complexity, what code is boring code. We need to be simple, boring, non-clever code. And instead, the tech business, the software business, has more and more exciting solutions and clever solutions. And that is a problem because for sure, we don't need cool solutions because they oftentimes have burnout affinity. That's what I learned. Cool, new, shiny stuff. No one used it in production. So cool is out of the thing for me. It's simplicity, it's boringness, it's non-cleverness. And the thing is, the sheer modern tech complexity is killing software developers' cognition. And I have this strong feeling that with AI, we put a cover or a sheet on top of that fact and put a different kind of cognition problem into the mix. We had one before. We could barely manage the sheer modern technology complexity, and now we cover it and generate the code, of course, which trained on all the solutions that we produced over the years, and which brought us to the point that the sheer cognition problem was there. And that is really something that I found very problematic. I tried to put it back to the thing. what you initially said, should we look at the code? Oh, yes, because we have this kind of cover on top of the thing if we decide to not look at the code. The worst thing that could happen is what happened to us in a project in 2010, model-driven architecture. Everything was generated. They put a generator for a solution, which was a CRUD application. What happened? They tried to change one internationalization string, and this thing generated for 1 day. What did they do? They froze all the code, and the poor developers needed to work on the frozen code because of investment. Sunk cost fallacy, of course. So what if AI fails in 3 to 5 years and everything is frozen because business decides to do so? Sunk cost fallacy again. Oh my God.
Okay, but my contention with this is, if, oh yes, we have to review the code, then why don't we just write the code? What's the point?
Exactly. The thing is, there's an irony there. If we decide to read the code, we could also write it. Simple, boring, non-clever, whatever. But that, of course, is expensive. And the thing is, if you generate, put the cover on top of it, it seems to be cheaper now. But what happens in 3 to 5 years is completely unclear to me.
Of course. But look, going back to human code review, if Joshua writes something in, let's say, C#, and now I'm on the team and I'm given the role or the task to review it, that really review it, that would mean that I'm at his level of understanding the domain and the language. And oftentimes I see people who are not clued in and just kind of rubber stamp something. This is a ceremony that projects the illusion of control. And so, you know, again, we need to be more serious about what this review and inspection mean.
The irony is, software reviews are not very efficient and good. It's an artificial waterfall step. Pair programming was there before code reviews. If you go way into the 60s, 70s, pairing was the thing. That was quality assurance. And somehow we lost that over the complexity mountains or whatever.
Well, but we're cargo culting it, I think, even though cargo cult is a bad word now. But another thing I just want to mention before we move to Joshua is simplicity is not boring to me. Simplicity is exciting to me. It takes a lot of intelligence to whittle down and to produce a simple solution that we go, wow, very exciting. So I just want to clear that it's not boring. Joshua, please, over to you.
Yeah, just to follow on, I guess, with that. First of all, with respect to code review, I mean, I think it's wonderful to have great practitioners, humans, to talk about design with, right? Because we're talking about design here. We're talking about how well designed the software is. But also, you know, one of my guru friends in AI who's been doing AI for 20, 30 years now. I mean, this guy is an absolute guru. He says never trust a single LLM. And so everything he does is always predicated on having multiple LLMs in the mix. Any result that comes back from an LLM, he's having it reviewed by other LLMs. And they're all kind of collaborating to decide what's the best here. And I think that's great practice. I've used it in some of the RAG work I've done. But to me, the hard parts of software development are still hard. And that's not changing with AI. I've worked with a large coffee company, had a wonderful idea that would have made them a ton of money. They had all these silos trying to build different pieces of it. And that includes IoT work, it includes mobile development work, it includes server-side work, all kinds of stuff. And every meeting would be like, no blockers, everything's good, nothing, there's no walking skeleton, there's no evolutionary design. And the thing never shipped, right? So it's like, how are we, so to me, that's a fundamental concept of evolutionary design. I don't see that being adopted around the world, even with LLMs and AI and all this stuff. We're not aware of the need to create a walking skeleton, maybe put it in front of people and learn what it needs to evolve, how it needs to evolve, so that we do the most minimal thing and get some value out the door. Right? We don't have product people on this call, but product people are going crazy right now saying, you are going to create an absolute mess with all your LLMs and all this code being generated. We need to, so to me, the hard part, and then, like, I've been developing this game, it's been wonderful, and we've already used it at a government agency that's adopting AI. And, just playing it with my daughters has given me tremendous feedback. Like, a teenager telling you stuff like, oh shit, she's right, that needs to be like that. And one of the things I've worked really hard on this game is resiliency. And if it wasn't for good design, I wouldn't be able to take the host of the game and just like close the browser on it. It's gone. And suddenly the player takes over as host. That's just not possible with what Claude was giving me. Simply would never have happened if I wasn't in the mix saying how I wanted this to be designed. So, the foundational stuff like evolutionary design, of course, automated checking, TDD and higher levels of that are hugely important. But to me, I think still we're in the vast minority here in terms of practicing like this. We really are in the minority. And that's my biggest concern, is that we're just gonna layer on AI, I think, as Alex was saying, and not really address the fundamental missing pieces, that are so fundamental to disciplined, simple, excellent software development. That's still a need, and a lot of people don't know that they need it. They don't know that they need it, and so they think AI is the latest thing.
May I add one facet? What you need for exactly that is a fabric of trust. And currently, the software developers are in fear of losing their job, and all the stress fabrics in the companies, in our culture, software development cultures, are strained or will be breaking. And for exactly what you just said, we need the exact opposite. We need a fabric of trust. And what the Agile Manifesto basically said, business and technology, the people need to gel, the people need to work together. And now we throw a technological solution that might destroy this very fabric.
But thank you, Joshua. That was a really good explanation. I just want to quickly point, and I hope Nicholas is still here. Yesterday, Nicholas and I think, at least to my impression, we did impose design, because first thing we did, we started with hexagonal architecture, hardcore boundaries. We put failing tests that are going to blow the whistle anytime the boundary is crossed. And that way, we are really kind of guiding LLM into a position where you just cannot trespass. And you have to, human in the loop, you have to know how to do that. You have to be around the block, you have battle scars, and then you can lead it. But I'm skeptical that a zero prompt, vibing can end up in a hexagonal architecture with all these ports and adapters and all that. That's not going to happen. Let's be realistic. So, you need, like Alexander says, trust. You need experts, proven people who have, like yourself, published authors, proven, reviewed by peers. Now you can learn something from them. Apply that to learn working with LLMs. Go ahead, Alex.
Plus juniors, and they are thrown out of the picture here. That's a big problem. We need new people, plus the trust, plus the fabric, together, forward, constructively, and not fear-mongering and all that stuff.
Yeah, but Woody's here. We are involving juniors in our mobs or teaming sessions. And high tide rises all boats. I've been in position to see, when I'm facilitating mob programming sessions, how even clueless juniors fumbling around quickly pick up those skills, and those skills stay with them. When you learn those skills in a team environment, when the clock is ticking, you're on a rotating timer, you better believe it. You pick up those skills and they stay with you. So that's one of the biggest groundbreaking things that Woody introduced in our profession, is this teaming, is this collaboration in real time, all the brilliant minds around one keyboard and one computer. Next is Laurie, please.
Yeah, thanks, Alex. I've been hearing the word government quite a lot, so and I think we must talk about that. This is a very topical issue. I mean, today is the deadline that the Department of War, or sorry, like in America, I mean, in South Africa, so I'm not 100% clued up on this, but so what's basically happening is that OpenAI and XAI have already budged to government pressure to remove safety guardrails for the use of their technology in warfare, right? And this is incredibly concerning. The only company that is still upholding their principles and staying steadfast here is Anthropic. What I'm super worried about is what's happening currently is something that happens on a periodical basis throughout the advancement of technology in the modern era. It's the malicious manipulation of algorithms due to pressure from powerful organizations that, in my opinion, overreaches overreaches or they cross the line of it's across an ethical line about what they may do with this technology and their powering to forcing companies to do things. What's currently happening now is that they are telling Anthropic to remove guardrails, or they will classify them as a national security threat, which would be the first time a technological company in the history of the United States has been declared a national security threat. And the deadline is today for them for what is about to happen. Now, there's someone on LinkedIn that I've been one of my contacts on LinkedIn gave me the link about this one post by Jonathan Desai, and he wrote in 2016 about the malicious manipulation of algorithms, and this was a long time ago, but it's kind of perfected, right? And he argues that the malicious manipulation of algorithms is everywhere, and it's distorting markets, coercing consumers, and of course spreading falsehoods. Now, what is happening, to Joshua's point, and to the other council members here, like you require business and technology and trust. No, what's going to happen when the public finds out that these companies were coerced into actually dropping paramount guardrails for safety and alignment and ethics with this incredibly advanced technology that is most likely going to propel us into the future, and they are budging towards governmental powers overreaching their might. So I'm very concerned about this. It has already come to light that Palantir employed Claude I forget now, in a previous operation, I believe, in Venezuela. Thank you, Jack. Yeah. So it seems to be the fact that they have also latched on to Anthropic. It might be that they believe that they have cracked something that the others haven't, and they are really looking for this technology. And if they start using it for the wrong purposes, if Anthropic budgets, for example, like, I don't see good things coming in the near future. So I think this is something that's really important to talk, perhaps, in the next session.
Thanks, Laurie. That's very important. I also would say this is a topic we should bring to our guild. We should probably have a separate session for the guild, and you can lead with that. And over to Michael H.
So I wanted to challenge your comment, Alex B, about if a human is going to review AI-generated code, why doesn't the human just write it themselves? That misses the whole context of what a review is. If you, at a high level, think of the craft of building software is like the craft of making an Irish whiskey. The whiskey gets better through subsequent distillations. And so there has to be the initial distillation to create the raw product, and then subsequent distillations to refine the product, possibly with some additions or changes in whatever you're making. And I think software needs to be reviewed like, or needs to be viewed like making a good whiskey. And so in that context, even if you're starting with AI generated code, that's still just the first batch of whiskey. It needs to go through subsequent distillations, and it might be subsequent distillations by other AI agents or other humans or a mixture. So I think that's my little golden nugget for the day. Just to reflect on that, I just was recently in Ireland, and I went to Glock's distillery down in Kinsale. They make Irish whiskey just like I described, but they also make gin. Gin is a completely different process. They buy the alcohol in a tanker, they put it in their still, they put the juniper berries in it, and in a week they can have gin on the counter, on the shelf for sale. Gin is a manufactured product. For all intents and purposes, let's call it an AI generated product, because there's very little craftsmanship involved. But there's other products that, like, they're good Irish whiskeys that have anywhere from 3 to 5 distillations. And I think the idea that, well, if I have to write it myself, then or I have to review it myself, I might as well have written it in the first place. You're missing a whole distillation there, a whole opportunity for refinement and improvement.
Thanks, Michael. I would just say we've been through that throughout our career, distilling, but without any LLM in the loop. So we have iterations and we have sprints, etc. We are reviewing and distilling our code. Now, if I'm going to ask LLM to write me some code, then I would hope that it can do its own distillation. It can keep going and reviewing its own code and distilling it. But if I have to do it, then I feel like might as well start from the get-go.
Well, no, because you're missing the opportunity to have an extra layer of distillation. You need to think of AI as your partner in creating this code. So you could write the code first, and then it could review it.
Okay, I'm fine with that.
Or the AI writes it first, and you review it. You got to think of it as a partnership, more of an adversary, or more than different from a problem to be solved.
I mean, if I hire a plumber, I'm not going to review their work, right? If I hire an expert, then I'm going to just trust it. Otherwise, I won't even bother, right? But I don't get, it's going to sound like a straw man to me, But anyway.
Tell me the last time you had somebody fix a tap and you didn't go and turn the tap on after to see if water came out.
But that's,
you do it anyway.
Yeah, but I don't go under and with the flashlight and check how the work went, Anyway,
now we're talking about the depth and detail of the review.
That's the review.
But I think you're missing the point that as many continuous distillation processes we can engage people or agents on, the better our software will be.
Of course, that's given, and we've been doing that for decades. But now that we have AI, I'm always questioning, like, why, if I have to now roll up my sleeves and spend hours reviewing, why don't I just write it myself, and then subsequently we can keep reviewing it?
Just take a different example.
You haven't been using AI the right way. My version of ChatGPT is customized so much, both explicitly and implicitly, that it behaves like I behave. And we've already talked about verification first as one of the customizations that I've done to my version of ChatGPT. So it knows what my likes and desires and my needs are, what my requirements are. And so it's like like, I'm not going to call it pair programming because I've never been a pair programmer, but you know, it's like having a trusted partner, and you're both like in a business, and you're both learning back and forth from each other. That's how you should be treating your AI agent. And if you don't, you know what? If you don't treat him that way, he's not going to act that way.
And you don't suspect any confirmation bias or anything like that. No, you're pretty sure that's the real deal. Anyway.
Well, no, I just like, well, I'm going to get a little pointed here. Are you the real deal? I trust you. What you say. I trust what Alex T says.
Yeah.
I trust Michael Kuhn. Everybody, to the extent that I trust them.
I advocate skepticism.
Let's just swap the example. You took the tab, and I was just motorcycling. And if someone worked on my brakes, I would check them before I go on my motorcycle ride.
Yeah, but that's simplistic. We're not talking about checking the behavior. We're talking about checking the structure. Code review is reviewing the structure, not the behavior. So the tab on the motorcycle is not
reviewing whatever the objectives of the reviewing are. You're backpedaling here, Alex. I think we have to leave it.
Look, automated tests are confirming and verifying the behavior, so you don't have to do it manually. But what you're doing manually, you want to check that the structure and the design of the code is to your liking. And that's nothing to do with slamming on the brakes or seeing if turn the tap. This is behavior. So behavior is automated. You don't have to do it yourself again, unless you're ultra paranoid and you don't trust your tests. But, you know, we have to kind of differentiate between reviewing for quality structure, for the design that's maintainable, even as the behavior stays the same. Nothing changes in terms of functionality. That's what I'm talking about, that kind of review.
I'm trying to decide whether to use the crying, laughing, or thumb on the chin icon.
Yeah, I mean, if you have automated tests and they'll pass, and now you have to do the pedestrian check everything, why do you even have tests in the first place? Right?
Let's step forward on this. There's two hands up before me, and I've got just way too much to say about this. Keep putting it off. So let's move forward a little bit.
Okay, Michael C.
Yeah, and I'll push back a little bit and sort of piggyback on what Michael H was saying. Basically, syntax is just syntax, right? The AI understands the code regardless of the syntax. That's the deal, right? That's why we trust it. We talked about it earlier. If you have a Java repository and you say turn it into Python, it knows how to do that. It knows the syntax of both. So when it's reviewing the code, or when you're reviewing the code, the question is like, are you reviewing for correctness? I mean, Alex, you said you're reviewing for design, but what are you looking for in that design? Is it that it's going to, you know, are you looking for efficiency?
You're looking for maintainability primarily, I would say.
But who's maintaining it? That's the question.
That's the question.
Right. If the AI is maintaining it, why do I care what it looks like? What I care about is does it meet the requirements? Do the brakes work at the end or no? And I think that's something that's really shifting the way engineers, especially junior engineers coming into this field, have to think about how they are truly collaborating. We talk about peer programming and how it's gone away. I don't think it has. AI is the peer.
Well, it's not shifting. It's not shifting because from the day one, we've been having separate discipline testing the behavior as opposed to testing the structure. These are separate concerns. They cannot be bundled together, at least in my experience.
Okay, but testing the structure, like you said, is for maintainability, making sure that humans can understand the code moving on. If we're delegating that now to AI and saying, well, it can understand pretty much anything I throw at it in any language, well, okay, then we don't necessarily need to understand the structure, but it still needs to be correct. And it still needs to scale. It still needs to be secure. Those things are the testing side. But at the same time, like peer reviewing and collaborating with the AI while you're, like, I love writing code. It's a craft. It's an art. It's sort of a very creative process for me. And I will write some things, but for the most part, now especially, it's more about how do I truly engineer the solution? How do I get it to decompose the problem in a way that makes sense to me the way I would do it as a human being. But I think it's my partner. This is something that I'm working with day in and day out. And if I hired an intern to do work for me, I obviously want that intern to do something. That's why I'm paying the intern. I won't review everything that the person did. I will ask questions, but at the same time, I do need to check that their work is actually like giving me the results that I want and test the things that I care about. So, you know, and someone mentioned agile, and I don't think the agile process is a fit for AI. That was made for human understanding and organization. AI doesn't really need that. I think there's a much more lightweight process that is much more collaborative, that still hasn't fully been developed, but it's evolving. And again, I think the junior people coming into this field, if they're allowed to come into the field, I think that's a skill that they're going to have to develop over time, and basically learn that AI is a first-class team member, and they have to figure out how to collaborate with it. That's just how I see it, anyway.
Thanks, Michael. Yeah, very interesting. I would like to introduce Christopher. I think this is your first panel discussion, Christopher. I know that Christopher is knee-deep in this bleeding edge. Oh, up to here. Okay. Over to you, Christopher.
Yeah, thanks, Alex. Well, you know, I mean, I noticed right away a lot of Michael's insights are deep and educated and spot on. So that was cool, you know, just to hear your points there. And both Michaels, you know, I thought you know, I like whiskey and I like gin. So I thought that was interesting, and especially the analogy of the gin, because, you know, you have this verified component, right? It's alcohol. Not much you can do with it, you know what I mean, to screw alcohol up. So we take that component, we add our flavoring to it, we have a product, right? It's a very different thing than iterative, right, with whiskey. And so I just think that a lot of the examples, you know, like the tap, right, and the water and the motorcycle and the brakes, as I popped into the comments, because I'm impatient, I don't know what to tell you, that is user acceptance testing, right? And as Michael Kuhn was pointing out, you know, and I think you had your points too, Mike Herman, you know, we're making these things. I do disagree with the fact that, you know, if I'm going to bother to review, right, I may as well have written it myself. That just, I don't personally feel is relevant with today's tools, right? You know, you can write up a React app at basically, I'm going to call it like 10x. Who cares if it's more than that? I mean, it is in cases 10x faster than I could be able to write it up. I could have the documentation in place. Like, you know, if I know how to jockey this horse, right, I'm at a 20x type of magnification of my physical abilities. So then what are we left with, right? What are our pieces? And I think your point, Herman, is that, you know, if we could reach for a component, right, somebody that made a QA framework that they may become, right, we're developers, we're engineers, some of us may specialize in QA. You know, I know a colleague who has been a QA professional for 25 years, and he built an agentic framework, and, you know, he poured all of his experience into it, and quickly learned that, you know, everything was, you know, flying colors with the agents, but ultimately when the humans got to it, you know, that wasn't the case. So there needed to be that multi-model verification. There needed to be that patternistic learning, which was a component of this particular system. And, you know, that's what I was just saying. I think, you know, Kuhn, you've been saying, you know, this is my partner day in and day out. I agree. You know, got like 3-4 Cloud Code terminals, and then you bring in, you know, Gemini to, you know, supposedly the thing that's the better, right, of the rest of the picks, and or Codex. And, you know, I mean, I've seen Codex act like a laughable level intern, you know, literally giving me words that are like, you know, well, I don't know, why don't you have Claude do that? You know, because I don't know, you know, I mean, literally, I don't know where it would come away, where it would be placed into the stream of professional tools with this ability, I wouldn't know, you know, but in any case, you know, dismissed, right? Like just like a human would be. So ultimately, I think that it comes down to that ability to craft a system. And it's honestly interesting to me that somebody with Anthropic's money, you know, the offshoots, the acquisition abilities, you know, that we don't have a persistent memory solid solution attached to either OpenAI or Claude. And, you know, whether or not we can easily plug in skills or anything like that, we still, I feel like as engineers, have to actually make things that can do what we expect them to do at a professional rollout, you know, emulation of a pro level process. And so that is all, I don't know, is that, you know, does that give us opportunities? Yes. Right. Friends of mine will tell you like, well, we should be worried that the big guys are going to eat our lunch. And, you know what I mean? I don't care. I'm not worried because in many cases, like the builder of a motorcycle, you know, I maybe prefer to build my bike if that was something I was going to ride every single day, et cetera, et cetera. I don't have to. Otherwise, though, you know, that doesn't mean that I don't appreciate a Harley Davidson or something to that degree. You know, the art and craftsman and, you know, 100-year tradition that's gone into, you know, refining that engineering process. I mean, there's probably a lot for me to learn, you know, from that element, you know. So in any case, I think as I think I heard this earlier, you know, we're early days in a lot of these cases. And when someone asked, I think it was you, Kuhn, that said, hey, what are we looking for here? Efficiency? Is it optimization? Is it maintainability? Right? You know, I think you threw in, Alex. And do I care, right? Yes, of course we care because optimization comes into it, efficiency comes into it. And to me, right, you know, somebody that, the word I learned to use over the years is elegance, you know, that essentially brings all that stuff together and is like, yes, you know, I mean, that's perfect, right, to the definition that we can take that word. And so, and we're way off from that, right? But yet, yes, agreed. You know, we can rip together an app that does X, Y, Z. I just talked to a non-technical individual who's more like sales solution. And he's like, oh, I put together an iOS app in a night, you know. And I met another guy this week that made $1 million this year putting together agents for lawyers. And I'm like, great. And he's like, but then I ask, is it scalable? And then it comes into, you know, the multi-tenancy and and other people, again, you know, the most aggressive entrepreneurial minds. You know, I've heard this said about people that I've met who've built a constant, you know, they built 50 production type level use cases out of these things. And you turn into their background and they're not even engineers. You know what I mean? They're like marketing guys or something like that because, you know, they could come up with a vision and do enough, right, to herd together the tools that they need to feel like, hey, this got tested. Let's see what a QA team could do. Oh, hey, you know, you made this thing that does QA. Cool. You know, let me check it out. And maybe I'm helping you test that and find holes in it, but also, you know, gaining efficiency from, you know, your work. So anyway, I don't know if I drifted there, but that's possible I do that. So thanks for the ability to provide some input.
Thanks, Christopher. I would just add, it's undeniable that this current state of technology is a power tool. And again, you know, Nicholas and I spent 2.5 hours yesterday. We built the system, and I'll be honest with you. At the end of the session, we ran mutation testing. We saw dozens of surviving mutants. If I didn't have this tool, I would just walk away and say, well, what you going to do? Surviving mutants, let's hope. But no, we just ask Codex, okay, kill those mutants, killed it all. I mean, just that alone is worth the price of admission. It's amazing. It's like rocket science to me, because I know I've been doing mutation testing for a long time. I've been leading more programming sessions, and at the end of each session, when we run mutation testing, we see surviving mutants. The team is struggling to kill it. This is not a trivial task. And so right there, then people say you are 2 on 2. I'm like, this is magic to me. This is like a genius can accept. Just go and kill all these mutants. Amazing. We're kind of trespassing now. I don't know how people with time. See, Grigori and maybe Alex can wrap it up and send us off to a beautiful weekend.
What about Woody?
Yeah,
Oh.
did I raise my hand?
Oh, sorry, Woody.
Yeah.
Were you next? Sorry, I
I
apologize.
It was
think I
lowered.
but I don't think that anybody has to hear anything I've got to say. And Christopher, if I don't wander off, you know something's wrong. So yeah. First of all, I've got too many notes in front of me. So the very first thing, Alex, that you brought up was about reviewing every line of code. I think you said that maybe the first or second thing you said. So the thing is, we're talking about code, and in reality, we should not be dealing with code anymore. I think that in practical terms, we use AI to write code, but we're moving to a new model, and that means it's not going to be about code. So we've invested our careers in code, and maybe we're kind of stuck in thinking about code. And I was just reminded two nights ago that I did my first programming in, I think, 1968 or 69, and I was doing pair programming. I was the one who understood how to use the machine we were using, and kids in the chemistry class would come over so I could do complex calculations for them. I was in the math lab or whatever. And so, we were pairing with a driver navigator. They would tell me what they want, and I would turn it into something they could use. So I've been doing these things for quite a while, but I want to kind of point out two or three things. If I go to get my car worked on, and they dig into it and say, we got to replace the bearings in the crankshaft, they can take those bearings out, show me that they're scarred or whatever they are, scored, and then I can say, okay, let's replace them. But once they've replaced them, I'm not going to say, take the engine apart and show me that you replaced them. I have to have a certain level of trust. And, maybe I'm listening for sounds that'll hint to me. So there's going to be some level of this, and maybe I'll finish my point with that. I go to AI, I say, take this, do some OCR on it, turn it into something I can place in my, maybe a ICS file or whatever that I can put it onto my calendar. So you can do that for me, and then I can show you these over and over, and you learn to do it better and better, and then you get really good at it. But I'm not looking at any code. They're doing the work that I would like to have done with code. But if it costs too much to have AI do it, I might want to say, why don't you write me an application I can run locally on my box to do this? And it has a heck of a time. It really struggles with that to get that working well. But that may not be true. That was something I experimented with, or I should say, I worked with someone who was experimenting with that 6 months ago or so. I'm not sure that the limitations are still there. So the last thing I think I want to bring up is, if we need to review the code, we can also have AI reviewing the code. So if we're using one particular environment, we can be using 10 environments, ChatGPT and Claude and whatever. They're all kind of the same, but we can say, here's the code we got over here, review this for me. And so reading really huge, complex files, which used to be a real challenge for me, or code bases, it's a lot easier using AI to say, hey, what's going on here? There's a lot of junk in here. Are any of these methods not getting called ever? And stuff like that. I don't need to do that grunt work that once, I had to do. Now, I have worked with people, and even in this meeting today, there are several who I think are way more brilliant than me and can look at a very convoluted base of code and say, oh, I know what's going on here. But that's not a particular skill I was ever very good at. So I wanted to close it there, but I'll add interns. I've worked at places where we took a group of interns who were not assignable because all the spots were taken, and we have some leftover interns. We point them at somebody who needs some code written, some project done, and they get let loose and they get it done. So let's not belittle interns at all. We need them, and they're thinking at a level that we can't think at anymore, because they're looking at it with all the garbage that clogs our brains. So I have lots more I wanted to say, but I think we've used up our time. And thank you so much. I love this opportunity to hear what these other brilliant people are saying, Alex, and that you've brought this together.
Thank you, Woody.
Yeah.
Thank you, Woody. But keep talking. If you have more things, I'm dying to hear them.
I have another 24 notes here. So I'll get you one more. Okay. Yeah. So there's this idea of working in pretend time. Have any of you ever read about that? You can look it up. And I think that we've got a lot of people doing things with AI, and it's similar to that concept that we're just doing what we need to do because it looks like we're doing what we need to do, instead of really moving things forward. So I think we need to be really cautious. I love hearing us talking about coding. I do think that, you know, that's a weight. That's like a, you know, we're going swimming with a weight tied around ourselves, and that's going to make it a lot harder. I think going forward, it's going to be a different thing. I don't know what that is exactly, but we need to start thinking about that. I don't think of AI as being a team member. Somebody mentioned that. Was that, well, yeah, there we go. It's a tool. It's more like I would never think of my skill saw as being a member of my team any more than my crosscut saw that I used to use. That was my grandpa's, you know. And yet I like to use that more modernized, faster tool. I can cut more accurately, faster, and maybe with a little more danger to myself. But so I'd like to just ask that we don't think of AI, or I would suggest that maybe we don't think of AI as being a partner, as just being a tool we need to get good at figuring out how to work with. But of course, I could be wrong with that.
Thanks, Woody. One thing that keeps coming back at me that you mentioned a few sessions earlier is it's a riddle for my brain, for my feeble brain. You mentioned that we are now using. Seems like we're using AI if we imagine a crazy scenario where we have discovered electricity and we now know how to harness it, and now we're using electricity to produce gasoline to, you know,
run our car.
So
that's right.
That's crazy. So can you, is there any other metaphor or angle just to shed some more light? Because I'm just like, this is driving me nuts. I'm trying to grasp it.
Well, so right, you know, I've been going through all my old notes over the last 25 years. And
yeah.
Some of you are in those notes. I'm not publishing any names, so don't worry too much about it.
Woody's files. Woody's files.
I have many companies I've been to where the notes are almost duplicated, where I'm going, I'm seeing these patterns over and over again, you know. And I think that the thing with we want to do things the way we used to do things in a better way. In other words, this is a leap. This isn't that kind of a thing. So, you know, like when I was a kid and learning to cut wood, let's use that for a minute. My dad gave me a couple saws that I could use. I think they were my grandpa's, but he said, okay, this one's a crosscut saw and this one's a rip saw. Some of you guys who do woodworking or people who do woodworking would know what those are. And then he just let me cut. He told me what they were for, and I would work for a while. And he'd come out and he'd notice I was having trouble. He said, boy, that looks like that's really hard. Is that hard to do? Yeah. He goes, why is it hard? You know, maybe this wood is harder. You know, he eventually got me to get around to saying, oh, I'm using the wrong saw for this kind of cut. So he didn't want to tell me I was wrong. He wanted me to think about why was I wrong. So I think that this is a very useful teaching mechanism that, because we can't skip to the end on teaching. People say, well, just tell me the answer. Like in my notes, I found the very first, in fact, it's fun to me right now. One of the very first questions I was asked on mob programming, one of the first two, in the first two talks I gave, or first talk I gave, was what's the right number of people to have on a team? So that's completely not a valid question. It's not something worth answering. It's not about a number of people, because you will see people in Scrum or these processes where they say, oh, it's 7 to 9 people on a team, or, you know, you use this Dunbar's numbers and things like that. So we need to be really cautious to, so we look for the questions that look like, this is the working on pretend time kind of a thing. We look for the questions that look like we've been listening, that make it look like we paid attention. But like in the dialogue, The Art of Thinking Together book, the guy says, the guy that says, shoot, let's skip your mind. Yeah, we're not listening to the other person. We're reloading. So Joshua, I do have conversations with the AI as well, but we need to be really careful about that. That's all I'm saying. So yeah, I'm on board with that. So anyways, yeah, I think paying attention to where this is going is way beyond what we're talking about, much of what we're talking about here. You know, with the coding and the reviews and TDD and all that kind of stuff. We need to invent a whole new level, a whole new different way of going forward with this. You know, we're going to have black boxes that are truly black boxes, so to speak. You know, that if we took the time to look inside of them, we won't have enough time in the rest of our life to do what we need to do. So I'll leave it with one last thing. I found all my notes on, I think I mentioned it before, everything I know about managing software development projects, I learned at the Battle of Stalingrad. Did I mention that before?
Nope.
One of these I've been in too many meetings lately. So this was, I read the book from Anthony Beaver on, if I'm saying his name right, the Battle of Stalingrad. And there was so much bad management on both sides of that thing that when you read the book, or I should say, when I read the book, page after page, I have notes stuck in there about, yeah, I've seen this pattern and I've seen that pattern. And I think we can learn from history. World War II happened before I was born, so I wasn't there to see it. But war had to change how it was being fought. We could no longer do things the way they used to do. I wish we didn't have to have wars or didn't have wars. But the point I'm making is people were doing things the way that made it, it's more back to the pretend time, made it look like we were doing the right things. So maybe in their pocket, it's always, who can I blame when this fails? We're looking for somebody to blame when this fails. So we've gone, Christopher, I hope I went enough off topic to satisfy everyone here. And I love this conversation. Though. Thank you for having it.
Brilliant, thank you, Woody. I will take some of your points to. I'm mentioning, really presenting to a large audience at a large government organization who are silly or brave enough to jump headfirst into AI native. Good. And they just want to, like you say, reinvent themselves. Just not only apply technology to the existing ways of working, but like, what can we?
Yes.
How can we reform ourselves?
So this is a problem with software in general that I've been noticing for decades, is people come to you so you can automate their existing paper process. When that paper process won't be needed anymore at all, you remember the old examples, like in a hospital, you go into one room, you have to fill out certain paperwork. You go to another room, you fill out the same paperwork. Well, you know, we don't need to duplicate those processes electronically. We need to realize we don't need those processes anymore. And of course, most systems don't have that anymore, but still some do. Take this form and go over there and you recopy it, you know. Anyways, yeah.
Yeah. Thank you, Woody. So just before we move to Grigori, I just want to, on the way to that opaque black box, I don't think we can make a giant leap. I think there's going to be a few steps in between.
Absolutely.
I'm going to just repeat what Joshua said here, which is 100% true. Software design differs from coding. Absolutely. And the first step in my mind, how we divorce ourselves from this fetish of the code, is focus on tests. To me, writing tests is not coding. And maybe that's the first stepping stone, I don't know. And maybe Woody, they just say we should be reviewing prompts, not even tests. And I don't know how far this is going to untangle. But this is brilliant. I appreciate so much what you guys have been telling me, because I'm preparing for, I'm really curious to see how this government organization is going, how far they get. This is an amazing experiment, and it just tickles my fancy. Anyway, in the interest of time, over to you, Gregory, and then Alexander can finish it.
So I think it's like ties to the start. It's like, what do we mean in reviewing? And Alex Turov mentions that, like, checking breaks after some work been done on them. So what I believe really interested is in properties of code. And I'll give you an example showing that we don't care about code. If you look at compilers, they produce horrible code. They don't respect the dry principle at all. They use unconditional jumps here and there, and we're fine with that. We haven't looked in a compiler, and then we have intermediate compiler, so it's even more further away from us from what we're doing, but we used to accept it. But it's not because it's just become common and usual. We share in properties of a code that compiler produce, and the same with code review and testing motorcycle. We actually care about properties of a system that's being built, and we looking at the code not because we're interested in the code. And counter example to what I'm saying is worked in a bank. I have to go through a code review with monetary authority of Singapore And what happens, they actually look at the code and they have to walk them all the way through, because it's like people from finance, they're like not like from software engineering, have to explain every code. They're like taking screenshot and recording like what I'm saying. Like to, in a sense, like we like ensure that bank is responsible for this code. But what we're asking for is like, we committed to ensure that properties of a system we build is aligned with financial regulations. And that's like biggest problem, like question, I believe, is like code we can like throw away like next day because like AI decided to rewrote it, or we switch to another programming language or tech stack. It does not matter. And therefore, we should not review something that does not matter, but we have to tell it like what we're interested in. We're interested in certain properties of code. And sometimes, as like an audit example, you have to look at code itself, because like testing properties any other way, it's not humanly practical. The system have like something like 47 tables of inputs, and like trying to model like all this like illegal practices, not reasonable time-wise. So we looked at the code, but like no one interested in the code for the sake of code. And we have to say, like, at what point we can be sure in properties of what AI produce, so we don't look at it. And people mentioned like maintenance multiple times. So if we sure into properties of code, if we can ensure properties of the system designed, then we can throw away code and ask different model to rewrite. And in the worst case scenario, we said like, okay, back to humans, like AI, like totally failing all of them. Like, so we should be like open, I believe, said like, we're not reviewing code for the sake of code, because I believe like I've heard arguments for and against, but for a different reason. So we have to come to like same conclusion, like what we're looking at code for, what do we want to see there? Like when we're talking about like maintenance, we actually talking about like how much money we're gonna put like tomorrow if we need to change system, if it's not satisfies certain properties. And then like when we calculating this money, say, okay, it would be 1 million tokens, or it will be like 3 software engineer days. How much does it cost? So like that's what we're interested in. And then when we put in review in, we say, oh, we want to avoid this cost, and therefore we're paying for review, so we don't have to pay this cost because they exorbitant, or we cannot prove a property some other way. But like we have to focus on like what are we reviewing for, and then we have like a clear delineation, like at which point we can stop reviewing AI code, because I believe this is like my end result. Like if we are continuously using AI, if it's like not some like ginormous flop, and we'll stop like using AI like like in a month, then endpoint is like we're not looking in a code of produced by AI, not maintain code produced by AI. Same with compiler, but we need to come to a way how we can ensure properties without looking at code and like just like drops an idea of like writing code and programming languages and so on, and it will be AI writing assembler or machine codes like specific to ARM, and there'll be no Java, C# or like whatever. Yeah.
Thank you, Grigori. I'll just quickly add, I'm going to raise the abstraction level one level higher. I spent a number of years working at a large financial organization, and I was collaborating very tightly with the compliance department. And it is a very dynamic domain. The government keeps changing the regulations and shoving, and I was actually leading and managing the systems development in that organization. And what I learned from them, and these are very experienced compliance officers, is that government regulations are a suggestion, and there's a lot of elbow room into how you as an organization interpret that and push it to the limit that you are not crossing some criminal boundary, right? And so different, even though different, all the financial institutions are going to get the same document that's dictating this is how things should be regulated, they all implement it differently. And it still works, it's still okay. So this is the human society, this is how we work. And I have a sense with this AI approaching that we give it a little bit of flexibility here. Like, hey, look, so long as these tests are passing, you're not surviving mutants, and whatever else you want to put in your pipeline.
I'm not breaking law, yeah.
Then, as Woody says, maybe this is a black box, and this is the battle we are now commencing here between us, where some people disagree and some people agree. But I think only time will tell. I'm more leaning towards for what you and Woody are kind of explaining, although I may be, again, proven wrong tomorrow. We never know. But so far, all the signs indicate towards, and even, you give the same source code to different compilers, they're going to produce different binary code. So they're not deterministic, like Alex
They
says.
both works. They have similar properties. Who cares?
Nobody's anxious and paranoid to check my binary code and make sure it's structured well. It works, right? And same is with the code produced by AI. It works. Now, is it maintainable? It's another question, right? But we are over time. So let's wrap up. Sorry, you have something to add, Gregory?
Yeah, so like maintainability, again, like maintainable is not a question that's self-explanatory. So maintainable is like, what does it mean? It's essentially how much does it cost to make a change to this software? And if we say, okay, like human will do it like in a month and say like, oh, this is horrible. We cannot like wait months like to make a change. But then like we have AI and we know like we have some ability to prove that like runtime agent, we have like some formal verifications like written on TLA or COQ, and they eventually satisfy it and they will do it like overnight. Next morning it will be fixed. Then say, okay, like maintainability of this code is cheap enough, however horrible the code is, because we gonna use like this approach. We will burn say like a million tokens. We'll pay $800 for this. It's acceptable. So maintainability of this code acceptable no matter what, and therefore we're not gonna look at the result. So you can easily check breaks when you like exiting the shop, and therefore you're not gonna stay over the mechanic's shoulder and look like at every step what is he doing, because you have a cheaper way to ensure properties of what's been built than actually like rebuilding and reviewing the code and like updating it. Yeah.
And another aspect of maintainability, everything holds what you said, but a few years back I was hired on a botched project, and they interviewed me a lot, etc., etc. There was a lot of things at stakes, and I joined and I spent a couple of days and just walked out. So they burnt a lot of time and money on me because I'm like, I'm not touching this with a 10-foot pole. I'm not masochistic. You find some other, masochist who's gonna squeal and suffer. I'm going after something that is going to be giving me more job satisfaction. So that's also the cost of maintainability, that you lose people. People become like this demotivated, right?
It can be infinite. Like you cannot find people who are going to maintain it, and therefore your maintainability becomes like an infinite cost. Yeah. You have to avoid it. Yeah.
All right. So let's bring it to the closing with Alex's predictions and warning signs.
Matt is not here, so I need to. Basically, what came to my mind when I listened to your discussion is that we are always moving only the complexity around in our business. We are never removing it from the system. Of course, the system consists not only of code and of technology, but also of the people and the structures in which the people work, in which the technology is embedded. So we are only shifting it around. Best example, for example, is microservices. There's a technical complexity shift there in the little spaces between those components. So we are always shifting it around. And I'm almost sure that we never remove it really from this system called software development, professional software development.
From certain,
sorry?
Not never, from certain points. So like we were removing, and then we stopped. At least, and it happens in the last 20 years that like I'm in a business. So like not always.
I'm not sure. The cognitive load aspect in the system has been massively increased, and it broke some backs, burnouts, whatever. So if you look at a system, not only at the technology facet of this thing, I am not sure whether we remove it. We are shifting it to other things, and we, of course, all the time financially evaluate, like money is something that tries to make it comparable. But before we go deeper into the rabbit hole, I really hope that speeding this up does not lead to multiplication of complexity later, because the cognitive delay might hit us later when we need to check all the things that are there. And And one thing Joshua said about the multiple LLMs, we have also an energy consumption aspect here. So we have one developer with N LLMs all eating up energy. So somehow we are brute forcing the quite energy efficient process that we have in this little thing called wetware, our brains. So we are somehow brute forcing it, and then we're throwing even more LLMs on one problem. That's one thought that came up when Joshua said that. And what we also haven't not really talked about, we are coming from a world of open source, even free software, and we're moving to a token cost factor and a black box model here. That is also an aspect that is, for me personally, problematic. So tokens are possibly the price for being pseudo fast if the cognitive load hits us later, versus an open source world, free, classic. And
cognitive load might hit LLM as well, not just us.
Sure. And possibly to close with this, I told you this story where the generated code 2010 was frozen. The same time I went on Twitter, I started to read on Twitter, and I read a really interesting sentence by a consultant, and I never forget that. Big bang projects are great. Be there when it's big and be gone when it makes bang. And with this thing that we just saw with OpenAI spending $1 billion to an Austrian guy, that is big. But I don't know what the bang is yet.
Yeah, I mean, these things are what we call the the watermelon effect. As the project progresses, it's green, 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 green. And when
Yes.
the delivery, you open it and it's all red. Now, just one thing that Woody said last time, and that really made my heart sink, which is, Woody, you described this process as a bulldozer, just pushing things, and that really worries me, and kind of,
Yeah.
I'm very concerned about that. Do you think, as Grigory said, that there is a point where we can kind of sublimate that garbage into a manure that can make something better grow, or just shoveling manure around, as Alex says? What's your take on that, Woody?
Yeah, so I wish I could figure out the future. I'm going to turn my lights on. Is that? No, that's no better. I can't tell the future. When I first was shown, I think I probably mentioned before, shown a mouse. I think I said, take a look at this thing. And I used it. And I said, who's going to use that? You have to take your hand off the keyboard to use it. So that's a waste. And so, you can see how wrong I was about that. And that goes with almost everything. So I know nothing about the future. I do believe that we are at a time of rapid discovery, that we may be, so we need to be careful about the kind of decisions we make now, and have to be very careful that we're not tricking ourselves. So, well, I'll use it. I've been studying a lot of World War II recently, mostly for the management aspects. But there was a time when the Japan felt they needed oil. They were dependent on the U.S. for oil. And so part of their goal was to find a source of oil they could have for their own. But it was too far away and had to be all moved by tankers and so on and so on. So it was unmaintainable. They had a situation where for 6 months, they could run a glorious campaign. After 6 months, things are going to slowly grind to a halt. Now, I'm not a historian. I'm not an academic. This is just me regurgitating what I've read others talk about. But you get the picture here, is that if we make the wrong kinds of calculations now, we're going to pay for that. And we cannot know the right kind of calculations to make. And that's why I like the agile approach to things, is we're going to iterate to it. We're going to discover it as we go, and we need to be really good at making decisions as we go. And of course, AI is good at helping us make decisions, but it can't make our decisions. We have to be very, very cautious with that.
I can make a prediction where it's going.
Yes, please.
I think I know where it's going. So it's a balance between what software provides, like what economic benefits it provides, and how much resource we pour into it. And it was such disproportionate that it's create a feeling that like it's okay to throw unlimited resources into software development. And there is a research approach when we're trying to tackle complexity, and there is just like dumping more resources into it, so we don't have to invest in the risky stuff of research because we don't know what would be the return. And AI came at a point, in a sense, like likely or unlikely from a different perspective, is like we were unable to throw more resources on software development. So we had like software engineers, but like hiring more, like we cannot organize them. So like we came to like conclusion that like we have to change something. Not a conclusion from economical perspective. We cannot throw any more resources to get like a meaningful result. And AI came with a promise, oh, now you can like throw electricity that seems like we can scale it. At least for now, we have like produced enough of it. And we just throw resources instead of tackling system like on tackling the problem at a systematic level and try to reduce complexity. So right now it's just a belief that economy is still holds like software, like engineering outcome will provide better economic benefits and resources we pouring in. And therefore we're just looking in a way to pour more resources in because we don't want to go like into research. And when I like interrupted Alex about like it's told like the clear examples, like compilers, we're not writing machine codes anymore. It tackled complexity immensely. Memory management was still part of like reducing complexity. We're not thinking in most cases about like, oh, how we organize stuff in memory. But at some point, like because we've seen outcome of software engineering, said like, okay, it's a number problem. We just need to pour more resources. And now AI say like, okay, we pour $1 trillion in AI infrastructure, and it will be like 20x benefits, because so far we've seen that software economical benefits like even exceed like 20x many times. So it's a believable practice from investor perspective. But like it will crumble under complexity because we're not trying to reduce complexity, and even AI like cannot like solve it without unlimited resources. So this is my prediction that like it crumbles before it gets better.
So Grigori, my question was not really about predicting the future. It was more about, can somebody envision this complexity, which, as Woody described, just bulldozing and piling garbage. Can someone envision a transformative, like see this garbage as a pile of manure that would feed a new breed of, would be technology or lifestyle or something?
Definitely. So like this pile of manure it's a problem for people who are doing research to solve, because like if you put like the smartest person in the room and say like solve a problem, but I'm not going to tell you like what is the problem, I don't give you data, he won't be able like to do it. So this pile of manure is a data from which we can get a solution to a problem, because like if you have like one example of a problem, it's very hard to solve it efficiently. It will be like over fitted. If you have like million examples, there's a higher chance that you will be able to solve a problem. But this bulldozer have to stack first before we start looking into manure and just like pouring like more horsepower and to show it like even further. And at the moment we develop like better engine, so we can get a more manure and show it like further down the line before we start actually looking into it.
Okay, and I think Alex would push back saying that this may be a giant solution in search of a problem, right, Alex?
I'm not looking into the future.
But do you feel that this is a solution that's running around looking for a problem, or is it a real solution?
I see high gain environment here, high stakes, high gain, and therefore incentive systems are massively broken. So I'm not sure. This is the crucial fact. The incentive systems, it's always about the incentive systems. If you look at any social organization, it is structured by means of incentive systems. And this AI thing, I don't see a very, very positive incentive structure in any way. So because of that, I see massive problems everywhere I look.
Okay. On that bombshell,
What a cheery note.
Yeah,
Okay.
that's it. Let's go. Let's go
Sorry.
drink. Let's go
Just
drink.
let us change the incentive systems, and then Alex will be more cheery.
Yeah. Okay, so guys, I really appreciate your passion. This is a very passionate group of people. You're staying for like almost 3 hours. But anyway, I hope we can continue next Friday. I don't know what everybody's schedule is. Let me know if this is not working, if you want a different time slot, etc. And I want to wish you a great weekend and a very productive week. And then we'll continue. I'm going to stop recording now.